This conference will now be recorded.
Fine. So we had started talking on Docker. We told that Docker is something which will bring virtualization into picture. And when I talk about virtualization, I'm sharing my resources with multiple resources, or I'm sharing my stuffs with multiple, or I guess I'm sharing my resources with multiple people. Okay. So good evening, Pulat. Now, when we started talking about Docker, yeah, please go ahead. If you have a question, you can please ask it. The question is perfectly okay. So you can ask your question on the chat window. I'll proceed with my stuffs. Now, if I talk about Docker, the Docker definition or the Docker stuff says build, ship, run any software anywhere. So in the previous class, we saw that if I have two developers who are working on my company, okay, there is a possibility that if I say them install these set of softwares, there is a possibility that one of them has a Mac operating system, the other one has a Linux operating system. Now, because they have a different operating system and they are installing different versions of the same software, there is a possibility that a software which is working perfectly fine, a code which is working perfectly fine on one of the machine is not working as expected on the other machine. So we say there are environmental dependencies. It's a very common thing which we see that a code is running very okay in my dev environment, but has issues when it goes to prod environment. So prod support guy says, it's not working, take it back. And the dev guy says, no, it's working fine. There's a problem with your environment. And this leads to the wall of confusion where at the end of the day, the customer or the end user is one who is suffering. So now what we do is we talk about containers. And when I say containers, I'm talking about a packaged or a stuff where I can put all the things which I need. So if I say container, it's a layer of image, mostly Linux based because Linux are small in size. And on top of that, I put my application. So now the expectation is that you do not have to install any software. You just need one single software, which is Docker. The moment you install Docker, you get a Docker environment, you get a Docker daemon up and running, and that is all what is expected. And then you can pull the images from the registry and start with your work. Okay. We saw that Docker is much more efficient than a similar technology which is prevalent in the market. A similar technology which is there in the market is known as VMs or virtualization via VM. But we saw that when we are talking about a virtual machine, this virtual machine, first, it's heavy. Second, it consumes a lot of resources. It's heavy because it comes with its own operating system. So there is a guest operating system. So when you install, there is a load on my existing application. So the existing application, I will say, is my host operating system, my host infrastructure, and this host infrastructure is burdened by new applications coming in. So what I see is that the CPU utilization goes up, the size goes up, the boot up time goes up, and net the maintenance work goes drastically up for me. So what I do is I move towards container. So if somebody says what's a container, I can say container is a lightweight VM, or container is also a VM, but it is lightweight. And why I say it's a lightweight? Because containers do not have any operating system, or this guest operating system component is not in present. They don't need any hypervisor. Hypervisor guest operating systems are the one which is making my VMs heavy. So I keep those two things aside and I come with something called Docker engine. The rest of the stuffs remain as it is. And now when I start using Docker containers, I can run n number of machines on my host operating system without bothering the host operating system. When I start using virtual machines, the CPU utilization is not very high. The size of my Docker containers are not very big. So the boot up time required, if there is this application has to be restarted, the boot up time required is also not very high. So net, I see the cost and the maintenance is low when I start using Docker containers. Memory usage, performance, portability, and boot up time are the four major factors which will differentiate my virtual machine and my Docker container. Then I came to know that when I start talking about Docker, I will talk about Docker architecture. When I talk about Docker architecture, I talk about three major components. One is your Docker daemon, the actual Docker engine which is running in the background, the Docker CLI, where I'm running all the Docker related commands, and Docker registry, which is the central repository which is going to fetch or which is going to store all the images which I will be created or are created by some other organizations. These images can be private or public. Public means anybody who has internet access can go view it and take a copy of it. So they can pull the image from DockerHub. If it's a private one, you will need special permissions or you will need ID and password so that you can log into that repo or that private repo and take the data from there. So private is something very specific to an organization or a individual, or public is something which is easily accessible. So there are these three major components. You have a Docker client where you write the commands. You have Docker host where the Docker daemon is running, and inside that Docker daemon, inside that Docker engine, the container and the images are running, and then I have the registry. When I say Docker image, I will say Docker image is nothing but it's a union of file system. Okay, so there are layers of files which are available here, and I just download or I just pull those images from my hub.docker.com. Then once you start running it, it becomes a container. So Docker images and Docker containers are not the same thing. When I say Docker image, it is just a read-only template. It is just a file system. Okay, you can build a Docker image. You can store a Docker image in your local or in your Docker repository. But when you run the same Docker image, it becomes a container. Container is where your applications are running. Containers are the one where all what you need to run application is present, and you can have one or more containers. Sorry, you can have one or more images running in a container. It is very important for us to understand that Docker images and Docker containers are two different things, or I can say two aspects or two sides of the same coin. Where do containers live? Definitely the containers are going to live on my Docker Hub, or the link is hub.docker.com. If I'm using a public repository, if I'm using a private repository, various cloud vendors come with their own, like Google has its own repository, Amazon has its own repository, like ECR, Amazon Elastic Container Registry. Like that, you can have private registries as well as public registries. When I talk about Docker registry, it's a centralized place where the code, where the images are going to get stored. This is what we generally do. We do whatever we have to, and then at the end of the day, if I want to make it accessible to all my fellow beings, I just put it into Docker Hub, and then from Docker Hub again, anybody can pull it. Again, they should have the proper rights. So this is being discussed again. Docker has an engine, and Docker engine has properties like it will give you isolated environment. You can create your containers, and the servers or the operating systems are shared, but are not. So this Docker engine is sharing all the operating systems and other resources, but they are not interfering into the normal working of the host operating system. And a container will have a life cycle. So you create a container, then it run a container, then you can start it, you can stop it, and then finally the container is terminated or it is gone. So this is what we generally do. We can go to log into Docker Hub. From there, we can pull an image, we can make changes, then we can store those changes on a Git repository, then again push that to DockerHub. From DockerHub, my Jenkins can pull that code, you can make changes, run the application, and then it's done. So we will see how we can create our own Docker images and get things done. So let me just move on. So we will see today what are the common Docker commands. Give me a second. Not this. Not this also, I guess. Not this. This one. Okay. So the first thing is, how do you install a Docker? So we saw it in the previous class. So I'll bring up my servers up first, so and then we can get started on that. At any point of time, if you want to have any questions or anything, please put it on the chat window, or you can ask directly. So I'll switch to my Mumbai region. Here I'll go to EC2. Okay, I don't have anything running, but I had stopped my Docker machine, which is here. So I'll bring it up. So it's a very good way of working. If you're not using them, just stop them so that they are not charging you for a container or for a machine which is running. Okay. So what happens is, the only problem which you'll face is that the public IP, when you stop it, the public IP is gone, and then a random public IP is generated. But if you don't want that, and you want that your IP should remain same, then you can go and allocate a elastic IP to yourself. And then in the action section, come here. In the actions section, just view details. Once again, go here. Action. This is saying release the IP address. One second. Action. Associate the IP address. Then you can associate your IP address with the instance you want. So I'm associating it with the Docker machine. So if I do something like this, this IP will get associated with my machine, and it will be kind of permanent. It will not change. See here, elastic IP, and it has become kind of permanent. What I'll do is I'll log into my environment. I will say EC2 minus user at the rate whatever IP address you got. Appearance, change the font size a bit, and DevOps Mumbai is the key I'm going to use. So SSH auth. Where are you? DevOps Mumbai. This is the key. Just go ahead and say open. It says, would you like to accept it? Yes, I would like. If I see here, it says that there are few packages which have to be updated. Please update them. So it is always advisable that if The system is asking for some update. Please go ahead and do that update. The second thing which I generally do is I become a root user so that I don't have any permission issues. And the third thing which I do is I give a host name to this machine. So I can say host name Docker engine. Okay, and again sudo su hyphen. So I can see I'm a root user and the name of the machine is Docker engine. Now, if you remember last time I ran a command called system ctl enable Docker. So if you run this command, what will happen is that the Docker itself will boot up when you start your machine. So I'll say Docker status, and I should, service Docker status, service Docker status. So you can see it is active and running. So I have not started it. Because of that command, service enable Docker, it will boot up or it will start whenever my service is or when my machine is starting. So my container or my Docker environment is all set and up and running. I have not installed any software till this point of time. Okay. What I will do is I want to see if some images are there. So I will say Docker images, or you can say Docker image ls. Your call. Both are same command and both are going to give you the same thing. So there is an image which is available here. The same command or the different command returning the same output. I can also say something like this, Docker PS. So Docker PS is nothing but it will show me all the containers. So you can say Docker, you can say like this, Docker container ls. This is the big command. So you can either say Docker container ls and show me the containers which are running, or the shortcut can be Docker PS minus a. Minus a is all, stopped, started, whatever it is. I want to see everything. So these two commands, Docker images and Docker PS minus a, you will be using very, very often. If you want to know what are all the commands which are being used here, you can simply come here and say Docker minus minus l. So it will give you a list of all the commands which are being used here. Most commonly used commands. So this is not a very big list. You can just walk through it and you will come to know that if I say Docker inspect, if I say Docker images, if I say Docker push, Docker pull, what do I mean by that? One more very easy way or efficient way to learn Docker is you can go to Google and say, I want Docker cheat sheet. You can say Docker cheat sheet. So it will give you a lot of cheat sheet. One of them comes from directly from Docker itself. So you can download it and you can keep it with yourself. It is very handy whenever you want to get started, do any kind of work. 1 second. Now, let's clear everything. Come back here. So I've installed Docker. Now, I would like to pull an image. So to pull an image, there should be two things. First, that particular image should be available here, where hub.docker.com. If it's a private repository, then you need to log in. So if you see, I have logged in with my credentials. If it's a public one where no login credentials are needed, you can simply go to explore and find it out. Like I'm looking for a machine called Ubuntu. Ubuntu is, everybody knows, it's an operating system. And you can see 1 billion plus downloads have happened. 10K plus people have given 5-star rating. So Ubuntu is a Debian based Linux operating system, which is free of cost. I would like to download this, or I would like to pull this. If I go inside, one important thing which I see is this is an official image. This is not a virus. This is not a malware or any kind of problematic stuff. It's an official thing which is coming from the company itself. How do I use this? It says Docker pull Ubuntu. If you simply say Docker pull Ubuntu, it will pull the latest version. But in case you want a specific version, click on this tags and go inside and see what tags are available. See here, the latest tag is the default one. Then you have Ubuntu rolling, you have Ubuntu Jammy. So there are various versions of this Ubuntu available. So I'll look for something which is very much small. So you have Ubuntu 20.04, you have 18.04, you have 21.04. Okay, so I will look for something which is very lightweight. So see here, there's a big list. These many versions of Ubuntu is available. So I will look for something which is very light. So to start with, I will come with something like this: Docker pull Ubuntu. If you want, you can also add the latest tag. Even if you don't add, by default, Docker will add it. See here, using the default tag latest, it is pulling the image. And if you see here, layer 1 is getting extracted and it has pulled the image from docker.io and the tag is latest. At this point of time, if I come here and say Docker images, I can see there is a Ubuntu image with this as an image ID. It was updated some 4 weeks back and the size is 72.8 MB. I don't want this Nginx image. I can simply come here and say Docker RMI, means remove the image and the name of the image, and it is gone. So you see, so many layers are deleted because it was downloaded in layers, so got deleted in layers. If I come back here and say Docker images, I can see at this point of time only one image, Ubuntu, with the tag as latest is available. Can I have one more image of Docker, one more image of Ubuntu with a different this thing? So this time I'm trying to pull a Alpine image of this. So it says error response from daemon, manifest of Ubuntu Alpine not found. So it is not there in your hub.docker.com. So I was not able to download it. So what I will do is I'll go here and look whether this Alpine version is available or not. So I can do no, it's not here. So what I will do is I'll go for Ubuntu and I'll go for some random version. Let me just come here to tags first. Let me go to 9. And here some bionic something is there. Okay, I'll do this. Let's pull it. See, there are layers to this. And it has been downloaded. A newer image has been downloaded. Docker images. I can see two images are there. One is this bionic one, which is some 79 MB. 3 years ago it was updated. This is the latest one, which was updated some time back. I don't need the bionic one. Docker RMI. If you don't need, right, just go ahead and delete it. Else it will simply consume the space and your machine will become slow. Now, if you want to see, you can say Docker images or Docker image ls. Yes, we have done. Now, I told that you can build a container out of this. Okay, so if you want to build a container out of the image which you have, this is the Ubuntu image I have. I can do run like this, Docker run, and I will simply say the image. I'll not say anything else. I will simply say Docker run latest. Now, if I don't say anything, okay, it will run in foreground mode or it will run in attached mode. So when I say attached mode, it will basically block my screen. Wait a second, no, what happened? Docker PS. Okay, see here. So when I say Docker run, okay, Ubuntu latest, you can see here a container was created with this container ID. A container was created with this container ID. It is using this particular image and it is running a bash It was created some 8 seconds back, and it exited in the sense it is stopped, and a random name, epic llam, was allocated to this. I don't want a random name. I want a proper name. So what I will do, I will say minus name, and I'll give a name as Ubuntu, my Ubuntu. My Ubuntu. This time, if I come back here again and say docker ps minus a, I can see that this is the container ID. This is the Ubuntu latest image which it is running. There is a bash command to this. It was created some 5 seconds back. Currently it has exited or it has stopped, but the name was given as per my requirement. Okay. These two are running. These two are exited. I want to just remove them. I can say docker rm minus f. So generally I remove forcefully, because many times when it is running and you want to remove it, it will give you an error. So I do run like this, docker rm minus f, and I will just come here, give the container ID. What will happen? Both the containers will be removed. And if I come back here and say docker ps minus a, I will see nothing is there. Means both have been removed. Okay. Now, similarly, I can run some other image also. So I will run this time Nginx image. Nginx. And I will say my Nginx. Okay. So you can say docker run, you give a name, and this is the latest image which you are running. Now you will say that you don't have a Nginx image here. Don't worry. It will first, it says unable to find Nginx latest locally. So I'm pulling that Nginx from your hub.docker.com. First, I will pull the image, then I will run this container for you. And because you did not mention anything, it is running in foreground mode, or this is the attached mode. So we say attached mode because now my cursor is blocked. I can't do anything here. So I have to do a control C. So the moment I control C, it exits or it stops. So if you, sorry. So if you come here and see, it was started some 30 seconds back, but it has exited. Why? Because I did a control C, because you were blocking my terminal. If you want that this should run in a detached mode, okay? So what you should do is, you can say docker run minus D. So minus D option will tell you that it is going to run in a detached mode. So this name has already been taken. So I will allocate a new name to this guy, my Nginx and Nginx latest. See here, this time because of this option as minus D, it just gave me the commit ID and it freed my terminal. My terminal is free. I can clear this first and come here and say docker ps minus a. So I can see from last 17 seconds, my Nginx 1 is running, and from a minute and before, my Nginx. So this is my Nginx 1, this is my Nginx. What if I want to give the same name? So my Nginx 1, this name I have already given. I will try to give it again. It will give me a conflict. It will say that this name is already in use. So you should better use a different name altogether. Come here. See here, this name is already being used. So what I can do, I can come here and say docker rm minus f and remove the 2. On top of this, there can be a requirement where you want to run this Docker image on a particular port number, which we say it's port forwarding. So Port forwarding is nothing but externally I want to see what is running. So this is running inside my Docker environment, but I want that what is happening in this Docker container I want to see from outside, means from internet. So there you would do something like this called as port forwarding. So for port forwarding, you use an option called -p and you say that 80:80. Or if you want to run it at a different port, give that port number 8080. That's up to you which port you want. So this is your external port number and this is your internal port number. If you see here, this one, I did not give any port number here. See here, I did not give any port number here, but here it is telling 80/TCP, means internally it is running at port 80. This time when I say -p this thing, I'm basically doing a port forwarding. I'm saying whatever is running internally at port 80, externally you project it or push it at port 8080. What is mean by internal and external port number? Okay, let me just run this first. Now, when you talk about Docker, so I'll give you a little bit of visualization here. 1 second. So this is my AWS. Where is this? Let me say this is my AWS world. Inside this AWS, I have an EC2 instance. Inside that EC2 instance, I have Docker installed. Inside that Docker install, I have a container running. So when it is running inside all this thing, I say it's a internal, it is running internally, it is running inside. But if somebody from outside want to come and see, or if this wants to go outside and show over internet, I say it is external. So anything which you want to put it to the outside world is called external. If it is inside, it is called internal. Okay. So what I have done right now is I have run this command, docker run minus. Okay, thank you. So I have run this command. It says docker run -d minus name, and then a port forwarding is what I have done. So due to this, if I come here and say docker ps -a, you will see here it is, or let me just copy this entire thing so that it becomes more readable for you. See here, this is my container ID. This is the image which is running. There is an entry point created. I'll talk about this entry point later. It was created a minute ago. The status is up about a minute ago, so it is up and running. Now, if you see this port, you can see here internal means internally at TCP or terminal 80 it is running, but 0.0.0 means internet. Outside world, it will be accessible at 8080. And this is IPv4 protocol. This is IPv6 protocol, and the name is my Nginx. Now you will say, what is IPv4? What is IPv6? Now, when we started with this internet, okay, there were limited number of users. So we used to have 32-bit of naming convention. So machines which were old machines, you will see the IP address will be like this. But at the end of the day, these are numbers. So there will be a point where you will exhaust all the numbers. So we reached that point, and much before reaching that point, companies realized that we need an alternate way of working. And that alternate way of working was IPv6. So when I say IPv6, it's a 64-bit protocol, sorry, 128-bit protocol. Just let me check now. So IPv6 is a 128-bit protocol, and the IPv address. So earlier we had only these many address space, 4.29 into 10 to the power 9, but this time we have 3.4 into 10 to the power 38 address spaces, means IP addresses. And if you say IPv6 examples, IPv4 address will be like this: 12 dot something dot something dot something, means 3 dots and some numbers will be there. But when you say IPv6, the numbers will be like this. So it is alphanumeric, you use numbers, and then each machine has to get a unique IP address. So we use IPv6 protocol here. Okay. Hopefully this is clear. So this one is for IPv4. This one is for IPv6. So I can see what is running at port number 8080. But there is a small catch here. Let me come here. So this machine is running at this particular IP address. Always look for the public IP. Private IP is for internal communication. So always look for the private IP. Come here and paste this IP address. Run it. It is not reachable. It's not running. You will say, no, you told it will run. I told it will run at port number 8080. See here, it is running. Welcome to Nginx, and you can see this running. No, this is different. I'll show you. If you come here and say Docker ps -a, sorry, small letter, Docker ps -a, this is what is running. If you terminate this, Docker rm -f, it is terminated. Come back here, refresh it. You start getting an error. What you did, you actually removed it, you terminated it. What I will do, I'll bring back it again. Come back here. See, it came back. It automatically refreshed and it came back. So that's the beauty of port forwarding. The only requirement for port forwarding is that your security group, in security section, you'll find this security group. This security group should allow the traffic. See here, for me, it is allowing the traffic at 8080. So this should be allowed. If you don't allow the traffic, it will not work. I'll give you an example. So this time I'm trying to run at 8081. If I come here and say, I can see it is running my Nginx 1 running at port 08081. But is it running for me? No, it will not run. It will hang. It will say I will not be able to run. Why? Because my security group is blocking it. So what should I do? Edit inbound rule and add a new rule. Just come here and say custom rule 8081 anywhere from IPv4, and just go ahead and save the rule. The moment you save this rule, immediately you will see it is started running. I did not refresh it also, and it started running. So that's the beauty of using port forwarding. Does internal port has to? No, not mandatory. But as per the convention, if you go to your hub.docker.com, right? And if you look for Nginx, it's official image. So if you go for, see here. As a convention, it says go for port 80, but not mandatory. You can try with a different port also, but it's good if you go for port 80 only. Now, come back here. I have this container running, right? I would like to delete it. Okay, docker rm minus f 1 2. Let's clear it out. Just check if something is running. Okay, nothing is running. Now what I will do is I'll run a container, but I will run in interactive terminal mode. I will say -it. So when I say -it, okay, it is basically trying to say that I am going to go inside the container and see what is happening. So if I run it as -it interactive terminal mode. So if now I come back here and say docker ps -a, I can see this container is running, okay, in interactive terminal manner. And this allows me to go inside the container. How can I go inside the container? The command is docker exec, means docker execute where -it, which is the container. This is the container ID. Where do you want to go? I want to go inside bin bash. So if you say like this, docker exec -it container ID bin bash, basically you are now going inside the container. See here, root @ the container ID. This is the container ID. Just see carefully. And here, if you do ls -l, this is being inside. There's a question here. Being inside container is not same being inside Ubuntu. No. Being inside container and being inside the operating system are two different things. So I'm here inside the container. Okay. So if I use docker exec command, I go inside the container. And then if I want to come out, I say exit, means bring me out of the container. Now I'm back to my Docker engine. So if I have to visualize this for you, one second, where is this? Again, back to my example. This is my AWS. This is my instance. This is my Docker, and this is my container. Now I'm going inside the container. I'm here. When you say I'm working, I'm here outside in the Docker shell or the Docker CLI. But when I say inside, I'm going inside the container. Why will you want to go inside the container? Many a times to debug. When something fails, to debug, you will have to go inside the container and see what is happening there. So you will go inside the container. And to go there, you have the command as docker exec. Okay. Now, when a container is running, you may want to stop the container, or you may want to start the container. So there is a command for this. If I come here and say docker ps -a, so I can see that this container is running. This container is running. I would like to stop it. I'll say docker stop and the container ID. So the status is up. Okay. Now I'm stopping the container. Docker stop. Now if I come here and see, it has exited, means it has stopped. I want to bring it back. Docker start. Up from last 3 seconds. You just want to kill it in the sense, kind of terminate it. You have killed it. You have kind of exited it. Okay. We have start, stop, kill, RMI. So these are done. Exec is done. This is done. Now, many times it may happen. Just let me just check docker ps -a. I'll remove this. Okay. So now Many a times it may happen, okay, let me say you are running a database, okay, or you're running a Nginx web server. Okay, what is Nginx? So any container which you're running, you just want to know what is that. So this is going to help you. What is Nginx? So Nginx, if you have worked with it, very good. If you don't have worked with it, then it is here. Nginx, pronounced as Nginx, is a open source reverse proxy HTTPS server. Now you'll say, what is reverse proxy? Now, what happens is, let me say I'm running a web application. So when I'm running a web application, I'll have a website, I'll have a web server. Let me say this is my web server. So if my web server directly communicates with the internet, there are possibilities that a hacker can directly come and attack my server. So I'm like open for attack, virus attack, or some kind of malfunction or malware attack. To avoid this, what I generally do is I put a proxy server in the beginning. So this is my web server, and just prior to that, I put a proxy server. Proxy server is very similar to the proxy which you put in terms of attendance. If your friend has not come to the college or he is absent and you just put a proxy for him. So my web will talk to proxy, and the proxy server will go and take the data from internet. So if a hacker wants to come and attack my website, he will never actually come to know where is the request coming from. So Nginx provide me that kind of protection. Not only that, it also gives me load balancing kind of thing. So let me say 2 web servers are there. So some request is coming. It will see this is already fully occupied. It will try to route the traffic here. So it gives me 2 kind of benefits, load balancing and the proxy security. Okay, so this is Nginx for you. Any doubts? Let me know.
So security means we can also apply some, like you told, port forwarding and some HTTPS and two-way SSL and things like that.
Everything. In fact, okay. SSL certificates and all are a part of Nginx, but because I don't want to go into web services and all, so I'm not covering that. But Nginx calls it out very clearly that we will be giving you all these features. HTTP, HTTPS, all those things will be part of my portfolio. Okay.
Thank you.
Yep. Can MS SQL Server run? Yes, definitely. If you want, you can run. So let me come here and look for a SQL Server or MS SQL. Wait. See, MS SQL test is there. MS SQL Server, something is there. Official one is not there. Okay. So it is owned by Microsoft, and I guess it's a licensed one. So they have not provided it. So you'll not get the licensed one, but the free ones will be available for you. Okay. But if you want the free ones, like this MySQL is free one. So MySQL you will find MySQL official. MariaDB is the free one. The Express version and all those things will be there. You have now MySQL Server. You have MySQL Server. The enterprise version you have. And it is verified publisher, means it's not the official image, but it is by Oracle. It's a verified publisher, so you will get the images on Docker environment. Okay, so now my stuff here is that I'm running a Docker container, and the Docker container has certain data. But if the Docker container dies, means somebody deletes the container, or by default something happens to my Docker container, along with that the data is also gone. So if I'm running a database and the data is only gone, then my work is gone into a toss, or I am into a big problem. So what I do is I start using volumes. So if I have to talk about volumes, I'll say Docker volume minus help. So if you do Docker volumes minus help, here it will talk about 2 things: Docker volume, which is managing volume, which is nothing but you kind of wait, just let me come here. I'm looking for that option. Inspect kill log port. Remove search stop. 1 second, update, wait. Do not find it. Wait, I'll find it out. Where is that? I'll figure it out. I'm not able to find. So when I say volumes, okay, basically what I'm trying to do is I'm trying to save the data which I have. So while I'm running the container, a lot of data will be generated, okay? Or if I'm running a web server, then a lot of data will be gathered. I don't want to lose that data. So what I will do is I will try to save, or I will try to safeguard that data. So for that, I'll be using something called Nginx volumes. Okay, for that, what I'm going to do is first, I'm going to create a volume. So volume is nothing but it's a storage component. So I'll say Docker volume ls. So as of now, if you do a Docker volume ls, you will not see any volume. Nothing is there. So I'll say Docker volume create sample volume. Means I'm creating a storage here. So sample volume has been created. If I come here and do Docker volume ls now, I can see locally there is a stuff called sample volume created, which is going to store the data. So I have kind of reserved the data. Where is that? What is that? So to know more about it, you can say Docker inspect and the name of the volume. So if you see carefully, it was created at this time. The driver is local. If you want, you can store it at different location altogether. That options are there. This is the mount point, or this is the place where it is actually storing the data or will store the data. The name is this thing. As of now, it is not attached to any Docker container, so nothing is there. Options local. So this is basically, this is very important, that this location is where it is going to store everything. So this time I will run my Docker container with that option. I will come here and say Docker, or let me run the same command which I have been running till now. So this is what I'm running till now. I will add one more flag here. I will say -v. So -v is volume. Where is your current setup? Okay. So current setup, 1 second. -v, all one. So -v. So externally, I want to store it here. What's the sample volume? Okay. Colon / internally, I want to store it at data folder, or you can put it like this. Once again, let me check if I've done it correctly. So primarily what I'm trying to tell here is inside the container, whatever data is getting generated in this data folder, externally, I want to store it here. Okay. So there are two storages which are getting linked with each other. One is this storage, which is named by this particular thing. And there is a storage which is internal to the container or inside the container. Both I am linking it together so that if there is something which is getting generated here or stored here, will be directly coming and sitting here also. Done. This time, if I come here and say Docker inspect volumes, so you can see here, okay, still nothing has been stored. No worries. So what I will do is I'll come here and say Docker ps -a. So you can see one container is running. I want to go inside the Docker container and inside this location. Okay. So first I will go inside the container. Docker exec minus it, name of the container, bin bash. Okay, where am I? I am here. If I do ls, I will see all the folders are here. I want to go where? cd, I want to go here, /data. I'm here inside the container, inside this data folder. As of now, I don't see anything. Nothing is there. I'll create a file. Nano. Let me say sample.txt. And sorry, nano is not there. So I'll just write something here. So echo is nothing but a print command. Sample data from container. Close it. Close it. So this is what I'm doing. Echo. Wait. If I say echo this thing, it will simply print it to the console like this. But I don't want to print it to the console. I want to redirect it to a file, and the file is file1.txt. Okay. So this time it will not print anything. Rather, it will go and put everything inside this particular file, cat, and the output is stored here. Now, where am I? I'm inside the container, inside the data folder, and I have created a file named as file1.txt. Now what I will do, I'll exit. Now where I am inside my Docker engine. I told that this path /data, which is inside the container, is mapped to this path, right? So what I will do, cd, paste it, remove these double quotes. So I'll go to this path and I will say ls minus l. What do you see? File1.txt, cat file1.txt. What happens? The same data which I had put inside the container is also reflecting here. Now I'll make some changes. Let me say, I will say echo added new line from Docker environment. To this file1.txt. So now if I just view the content, I can see two lines are there. From where I'm editing it from the Docker engine. Now again, if I go inside my container, which is Docker exec, this thing, and I go to my data file and I do ls minus l, I can see this, I can see this file is here. And if I view the content, you can see this new line is also added. It means my volume, Docker volume, and the content inside the container are in sync. You can exit from there. Now, the beauty of this is that if due to some reason the container crashes or the container dies, there is a possibility, right? The machine can crash. So I know this container has crashed. Docker rm minus f, the data is gone. Docker ps minus a, the container is gone. In general scenario, the data would also have been erased, but now that's not the case. I still have the data locally stored at my environment. Now I want to run a new container with the same data. What I will do, I'll run the same command, docker run, and I will give sample volume data. Enter. Now what I will see, if I come here and say docker, and this is the container ID, right? Docker ps minus a. This is my container ID. So if I come here and say the new command, which is, so earlier the container ID was this A6 something something something. Now the container ID has changed. Means I'm running a new container. The beauty is the data will still be there for me. Sorry, file1.txt if you want. So this way of working is known as data persistence, or we say Docker volume. So if I start using Docker volume, I make my data persistent. It means even if my containers die, my containers crash, okay, I will not be seeing the data is getting lost. One more way of working with this is bind mount, which I will teach you tomorrow. Okay. As of now, this is what we have. We have Docker volumes. We can go inside the volume. Whatever data we have, we make it persistent. In which case we use Docker commit command. Commit command will also come. So on the fly, if we want to make some changes, then we use Docker commit command. So let me say this container is running. So this container is running. I want to make some changes, and I want that those changes should reflect. Then I will use Docker commit command. So tomorrow I will take that also. Docker commit. What is Docker commit and how it will help you? So that's Docker commit, Docker bind mount, and Docker file, or the custom Docker images is what I will teach you tomorrow. Okay, guys. Then what we will do is we will drop for today, and we meet again tomorrow, and we will start from there. If for today you have any questions, anything, please let me know. If you don't have any questions for today, we can drop and we will resume tomorrow. Yeah, you can go ahead. You can put it on the chat window. I'll just exit from here. Is it a correct way to store images on this way? Generally, what you don't do is you don't store your images on a public repository. It is always advised that you create a private repository and store your images there. In Jenkins, take the source from Git, build with Maven. If yes, what is the use to upload it in a container? What is the use? I did not upload it to a container or a VM. Rather, I would always prefer to put it in the code, the source code which you're writing. I'll prefer to put it in some GitHub repository, and from there, the GitHub repository should be linked with the Jenkins build tool, which will take it and run it for me. So I will not prefer to store it in a VM or a container where the possibility is that it may crash. Okay, so not a right way to put it into a container or a VM. Okay, fine guys. So I see these many questions are there, and we meet tomorrow and then we continue from there. See you then guys. Bye-bye.